Okay. Good evening, everyone. My name is Chandan Kumar Gupta. I'm a Prime Minister Research Fellow in Department of Mathematics, IIT Patna. Today, I'm your NPTEL Teaching Assistant for the course Introduction to Probability Theory and Statistics. This course is offered by Professor S. Dharmaraj. He is currently a faculty in IIT Delhi. Okay. This is the first week of a 12-week course. So I hope everyone watches the video. Okay, since it is first class, so let's start with some basic introduction. If anyone wants to introduce yourself, then like they are welcome. Anyone? Okay, my screen is visible, na?
Yes, sir.
Okay. Okay, so I think everyone have already watched the videos. So let's have a recap of the last week lectures, and after that we will solve some numericals on the basis of those lectures. Okay. So
Sir, can I ask one thing?
yeah, sure.
Sir, will this lecture which you are taking now will be given in this TET course also, the recorded version?
Yeah, the record actually like I need to like provide this recorded lecture to NPTEL team. They will probably provide you some link. Okay, from there you can access all the links as well as the PDF, which I am currently using this PDF. This PDF is also provided to you by the NPTEL team. Okay. Or you
Thank you,
can
sir.
directly like yeah, you can also see those lectures from this YouTube channel. I need like I have to upload this on this particular channel. This is my YouTube channel actually. Okay, so from there you can also watch these lectures, but they will provide the same link that I have provided to them. Okay.
Okay, thank you, sir.
So okay then let's start. Okay, so let's start with the syllabus actually. Okay, so like in first week we will discuss about the basics of probability. Okay, so basics of probability in which we will discuss about the definitions of probability, the random experiments, the outcomes, and the favorable and unfavorable events. Okay, the conditional probability, the independence of events, and the total probability theorem, and at last the Bayes theorem. Okay, which is a uh, special version of like conditional probability. Okay, like in week 2 we will discuss about random variables. Okay. In random variables, we will define discrete and continuous random variables and a mixed version of discrete and continuous random variable as well. Okay. So in the third week, just a brief intro, I'm going to discuss about the particular course. Okay. And after that, we will start with some topics that we have covered in the first week lecture. Like in the third week, we will discuss about moments. Okay. Moments and inequalities. And in which higher order, first order, and second order, like central and non-central moments are discussed. Like central moment and non-central moments are two different things. Okay, and after that, higher order moments are also used to estimate the skewness and kurtosis of the data. Okay, and in the fourth week lecture, we will discuss about the standard distribution. Okay, in which we will discuss about some well-known discrete and continuous distributions like binomial Poisson distributions are there in terms of discrete distribution, and in case of interval distribution, sorry, in terms of continuous distribution, we will discuss about like normal, gamma, beta, and many other distributions are there. So we will discuss about these distributions and their properties and in which scenarios which distribution is used. Okay. If anyone have any doubt, they can directly ask. Okay. This is actually just a discussion kind of thing. So not like a regular classes. Okay. Now in week 5, we will discuss about higher dimensional distribution. Okay. Higher dimensional distribution means like we will discuss about bivariate distribution as well, trivariate. So in terms of like bivariate, trivariates, we will call them a multivariate distribution. Okay. So we will discuss about some multivariate distribution, their joint probability density function, their joint, their marginal functions distributions as well, and independence of those like random variables. These kind of things are learned in week 5 lectures. Okay. Now, in the 6th week, we will discuss about functions of several random variables. Functions of several random variables. Okay. In this, we will discuss about ordered statistics. Okay. Conditional distributions like suppose x, y are bivariate distribution. Then what is x given y equal to y? This kind of distribution we will discuss in 6th week lecture. Okay. And in 7th, we will discuss about cross moments. These are already discussed by the like Dharmaraj sir. Okay, but I just take a brief. Cross moments are also discussed in week 7, in which moments of functions of several variables are discussed. Variance covariance matrix, how to form variance covariance matrix, and what is the use of those metrics. Okay. Then correlation and regression analysis is also there. It's a just a definition is there in week 7. We will discuss about the correlation and regression analysis in the 12th week actually in a detailed manner. Okay. And in 8th week, we will discuss about limiting distributions. Limiting distribution like weak law of large number, strong law of large number, modes of convergence, and central limit theorem. Okay. 9th week, from up to 8th week, we will discuss about the probability theory. Since the course name is Introduction to Probability Theory and Statistics. So up to like, just a second, up to like 8th week, we will discuss about probability theory. And in the last 4 weeks, we will discuss about the statistics. Okay. And in statistics, we will discuss first descriptive statistics, like measure of central tendency, measure of dispersion, skewness, kurtosis, and sampling distribution are discussed in this particular 9th week lecture. Okay. And in the 10th week, we will discuss about the inference. Okay. Point and interval estimations. Okay. Since point estimation and interval estimations are discussed in interval, in week 10th. And the 11th, we will discuss about testing of hypothesis. In which we will discuss about type 1 error, type 2 error. Okay. And testing of means variance was also discussed in the 11th week lecture. Okay. We will discuss like what is hypothesis, what is the meaning of point estimation and interval estimation in that particular week. Okay. Just I'm telling you what we are going to discuss in the whole 12-week lecture. And at last, we will discuss about analysis of correlation and regression. Okay, what is the differences between correlation and regression, how it is calculated, and how the coefficients are interpreted. Okay, these are discussed in the last week of the course. Okay, anyone have like any doubt or anything they want to ask, they can. Okay, or we will start with the basic theorems or details or definitions. If anyone have any doubt, they can. Okay.
Sir, the numericals will be also solved in this regarding
Yeah,
the
actually, I
topics.
have some. Yeah. Actually, I have some numericals. Okay, we have already like prepared those. Okay, those are like similar to the assignments that like is provided to you. Okay, so with the help of these particular solved examples, you are able to like solve your assignments. But in case you want to ask anything, we can like give some hints or some particular concept. With the help of those, you can solve the particular current assignment as well. Okay.
Okay, sir.
So actually, we are like here only to discuss about the concepts. Okay. If you have any doubts, since the lectures are already recorded. Okay. So there is no live interaction with the professors. So we are here. You can ask us. Okay. You can ask me any doubt regarding the questions, regarding the topics or the numericals. Okay.
Okay, sir.
Okay then. Yeah. Okay. Then starts. Okay. So like the name of the course is Introduction to Probability Theory and Statistics. Okay. So there are two terms actually, probability and statistics. And these two terms are like complementary to each other. We can say that they are highly correlated to each other. We will like although we will there are two different topics, probability theory, in which like we assume that we know about the characteristics of the population. Okay. And with the help of those known values of the population parameter, we will solve the numericals or questions or frame the problems. But in case of statistics, okay, our aim is to calculate or estimate those parameters, and this can be done with the help of the sampling. Okay, so we take some samples, and with the help of those samples, we are able to predict or estimate the values of the parameters. Okay, so like we can say that suppose like I'm in IT Patna actually. Okay, suppose this is IT Patna is the whole population for me. So in that case, I say the average height of person is known, of the students in IT Patna is known. So if it is treated as a population, then average height is a some parameter. Okay. So it is already known. But in so this particular problem comes under probability theory. Okay, because it is known. With the help of those, I can like okay, let me write something. Let average height of population, in terms of population, I'm telling. Okay, suppose 165 centimeter. Okay, then it is known na. Then I can ask what is the probability that what is the probability that a randomly chosen person is having height 178 centimeter or more. Okay, then since it is known, we can solve. We have already the distribution of the those data, then we can solve these. Okay, but in case of statistics, our first aim is to estimate it. Okay, estimate this height. And this can be done with the help of sampling procedure. Like there are around 5,000 students. Okay, so I'm not going to ask the five about the height of those 5,000 students. I'm going to randomly or some other method select 100 students and make the average of those 100 students, and maybe it may comes around 168 centimeter, 159 centimeter, or so on. So I will repeat these process 2 3 5 times, and after that we will approximately able to estimate the average height of the population with the help of these sample values. So this particular techniques comes under the statistics. Okay. So these are like the differences between probability theory and statistics, but both are like simultaneously used. are like complementary to each other actually. Okay. So in week one, our topic is basics of probability. So we will discuss about the probability. Okay. So in probability, as we have already learned in 10th class or 11th class or something. So probability of any event, suppose it is denoted by E, okay, is defined as the number of favorable cases upon total cases in the sample space. Okay. So these are the very basic. This is actually the classical definition of probability. Okay. Uh, so here we term like use the term event is there. Okay. Sample space is there. Okay. Favorable case is also there. So these terms should be first defined so that we can understand this particular definition of probability, and after that we will learn about the axiomatic definition, which is currently the latest definition of probability. Okay. So like the first one is like a random experiment. Okay. Like any experiment, okay, is said to be random experiment, which outcome or result is not known prior. Okay. Like we will not know the result beforehand. We will only know the result or outcome of that experiment after we perform that experiments. So these are called random experiments. Like the very basic example of tossing a coin. We know that when we toss a coin, it may either head or tail occurs. Okay. So we will get either head or tail, but we will we don't know which either head occurs or tail occurs at that particular trial, but we know these two are the only possibilities that will going to happen. So these are called the experiments. Tossing a coin is a random experiment. In a similar manner, like rolling a die is also, we will get 1, 2, 3, 4, 5, and 6 as a outcomes. Okay, so these are the only 6 possible outcomes. Okay, so these are called the random experiments. Okay, and the second one is called sample space, which is also denoted with like either omega or capital S or some other symbol as well. But in usually we will denote the sample space with omega. So the sample space is defined as the set of all those possible outcomes that happen in a random experiment. Okay, like here, it is a sample space when we toss a coin. Uh, this is also a sample space when we roll a die. Okay, when we like toss tossing two coins, when we toss two coins simultaneously, in that case our sample space will be like head on both sides, both the coins. The first one has head, the second one is tail, the tail and the head, and both occurs tail. Okay, so these are the our sample space when we toss two coins. So this is the random experiment, and this is the all the possible outcomes. So this is random experiment, this is a sample space in this condition. Okay, so this happens, and after that we will like we will define the axiomatic definition of probability. For that we should know about the sigma field, subsets. These all like in set theory we will already discuss about the uh, what is set, what is a subset of a set. So in a similar manner, here we will define the sample space and then the event. Event is also there. Event is actually, wait, let me define event as well. Events are actually subset of the sample space. Okay, in short, we can say that in a simpler manner, we can say that events are the subsets of subset of a subset or subsets, both are possible actually. Subset of a sample space. Okay, this is called events actually. Okay, so when we have sample space, then what is the, like, we will ask about the question like, what is the probability that two head of questions like we can ask, and suppose two head occurs, if I say, then event one is only HH is there. This is nothing but a subset of omega 3. Okay, subset of omega 3. So we can say that events are nothing but the subsets of sample space. Okay, but we will define it in terms of like probability space. Okay, so first we need to know about the sample, sorry, sigma field or sigma algebra, and then after that we will define the probability space. These are already discussed, just I'm just revising actually. Sigma field. Sigma field actually, it is a collection, usually denoted by curly f or f. Okay, a collection f of subsets of the sample space omega is called a sigma field. Okay, if this follows some properties, like the first one is like the sample space itself belong to this particular field. The second one is like if any event A or any element A belongs to this F, then its complement should also belong to the same field. Okay, so we say that. And also there is the third point. If we have A1, A2 up to AN and so on, these belongs to F, then arbitrary union of this should also belong to F. If these three condition holds, then we say that this is a field. Okay, over this set. Okay, so this is our sample space and this is the field, which is nothing but a form of a collection of subsets of this omega. Okay, we can all like, we will already know that na, like sample. Okay, anyone know about the power set? Anyone?
Yes, sir.
Can you explain what is power set?
Collection of all subset of any set.
Okay, this is right actually. Okay, like here as example, we will take tossing a coin as a random experiment. Then our sample space is like head or tail. Okay, so all the subset of this set is like written as the power set of that set. Okay, so let me write power set of this. It is a collection of all those subsets. Okay, this, then the first one is like phi, empty set, already always a subset of every set, and then H, T, and HT, which is nothing but omega actually. So 1, 2, 3, 4. So there are four subsets, four elements in the power set of omega. Okay, so this is also like sigma field or sigma algebra. Okay, this is also a sigma field or sigma algebra. But besides this, we can also like make the power set. Sorry, not the power set. Here actually, okay, let me write some. Okay, F1. F1 here, F1 is the sigma field or sigma algebra for the for the sample space omega. Okay, we can also like define F2 here, phi and omega. This is also a subset of this sample space omega, but it does not contain all the element of like all the subset of this omega. Okay, but still it is a like sigma field. So we can like say that there are more than one sigma fields exist or available for the given sample space or set. Okay, that means it is not unique. It may be unique for some particular set, but it is not unique. We can define uh, more than one sigma field or sigma algebra for the particular sample space or set. Okay, we have all like in lectures already there are so many examples are discussed. I'm just taking the simplest one. Okay, and also there are Borel sigma field is there. Okay, when we take Borel sigma field or Borel sigma algebra is also there. When we take the sample space as the real line, then in that case, the like the largest sigma field over the omega, or the real number, which is the power set of this sample space, is called the Borel sigma field. Okay, like we can define if the sample space is real line or real number, then in that case, the largest sigma field over omega is called the Borel field. Okay, and the largest one is also the power set of that particular set. Okay, but in case of real number, real line, we will like specify like we can define it in a more spatial manner, like Borel word is also there for Borel sigma field, then that means our sample space is real line. Okay. And after that, okay. Now we will define the definition of probability. Okay. Now we will define the axiomatic definition of probability. Actually, this axiomatic definition of probability. This definition is given by Kolmogorov. There are three axioms actually. Okay, if any function is said to be probability function, then it must follow these three axioms. Okay, the statements are like let omega be a sample space. Let omega be a sample space. Okay, and let f be a sorry, let f be a sigma algebra or sigma field. Okay, then we define a function. We define a function, p function. Okay, this is also probability function. It is a real valued set function. Actually, it is a which is also known as probability function from this field to real number. And this real number is actually in between 0 to 1, closed in 0, 1. So this p function is called probability. When probability or probability function, when the first three properties are holds. Like the first one is like probability of any A is greater than or equal to 0 when A belongs to this field. So from here we can see that A is an event, and event comes from this F. F is actually nothing but the subset of the sample space F. Okay, so event is defined from the field actually. Okay, and the samples are taken from the sample space. Okay, the second one is like second axioms is like probability of the sample space equals 1. Okay, and the third one is if we have A1, A2 up to infinitely many mutually exclusive events. If we have A1, A2 up to infinitely many mutually exclusive events, those are taken from the field F, then in that case, the probability of union of these events is equal to summation of probability of the events. If these three axioms are hold for a function, then we say that this P function is actually nothing but the probability or probability function. And then we say P is the probability, and this space omega F and P is called probability space. Okay, so we can define the axiomatic definition of probability by considering a sample space and the corresponding field, and we define a probability P in such a manner that the map it maps them to a real number which bounded to 0 and 1. Then this P function is said to be probability if these three conditions holds. Okay, and we can also see that like uh, for the same sample space and same sigma field, we can like define different probability function. Okay, so for the similar sample space and sigma field, we have different probability function exist. Okay, like if we have all sir have already discussed an example actually. Let me. Okay, still head and tail. Okay, and suppose the field has contained like phi, head, tail, and omega. Okay, this is the field, this is the sample space. Okay, now we define the probability function. Suppose 0, 1 by 5, 4 by 5, and 1. 0 when A equal to phi, 1 by 5 when A equal to head, 4 by 5 when A equal to tail. This can be written in actually curly bracket, and A equal to omega. Okay, in a similar manner, we can define the probability function in that way: 0, 2 by 3, 1 by 3, 1. Or we can define P3 like 0, 1 by 10, 9 by 10, and 1. Okay, this is for phi, this is for head, this is for tail, and this is for like omega. And still phi, even head or tail can be exchangeable, like for tail, for head, and omega. Okay, so for the same sample space and the same field, we can define different probability function or probability for the under like these conditions. Okay, I think someone asked any question. Wait, let me check. If anyone like have any question, they can ask directly because I'm not like looking in the chat. Okay. Yes, recording is like available to all of you. Okay, well. Okay, so this is the axiomatic definition of probability, and from that we will define the probability space over the given sample space. Okay, so we will also define the measure or probability measure, which can be defined in a similar manner when like when these three axioms, na, when we omit this second axioms. Okay, since like P is a real valued set, sorry, since P is a real valued set functions. Okay, and suppose this P satisfy the axiom 1 and 3. Okay, then in that case it is called measure. Okay. Measure is defined as like when P is any function, real any real valued set function which is already defined in the above. Okay, and it satisfies axioms 1 and 3, then it is called measure. Okay, and if it satisfies like for any finite value of axiom second. Okay, here it is 1. You may also like take the value 1 as 3, 5, 7, 9, and any value. Uh, and it and if it satisfy like axiom second for any finite value, then it is called normed measure. Okay, so this is measure. Example of measure are like again head and tail, and we can omit the second variable, then it is measure. Okay. Okay, Neha, the recording will be like you will be provided a link actually from the NPTEL team. Okay, so either you can get those link or you can follow the YouTube channel that I have shown previously, or I can share the at last the detail as well. Okay, so from there you can see the recordings of these lectures and the PDF also available in the drive. Okay. Okay. Okay, then let's start. We have a question actually also. Some other properties of the probability. Let me write one by one. Like the properties of probability. We know that like na, since the probability of the sample space is 1, so the probability of any null set is equal to 0. Okay, if like two events A and B are two events which taken from the sigma field F, Okay, then if A intersects and B equal to phi, that means A and B are mutually exclusive events, then in that case, the probability of A union B can be written as probability of A plus probability of B. Okay. Also, like for any event A belongs to the sigma field, the probability of A complement is defined as 1 minus probability of that event A. Okay. And in general, the addition theorem will be like if A and B are two events from the sigma field F, then the probability of A union B is defined as probability of A plus probability of B minus probability of A intersects and B. Okay. These are just simple example, simple property of probability. Like if anyone have any doubt how this particular property comes, then they can ask. Okay. Also, we have uh, the we actually wait. Okay, these are some of the properties actually. So no need to write all the properties already discussed. And the classical definition of probability is already discussed, like the favorable outcomes upon total outcomes. Okay. There are some terms like equally likely events. Okay. Those events. Okay. Let me write here. Equally likely events. Those events who have the same probability of occurrence. Okay. Events having the same probability of occurrence are called equal likely events. Okay. Like mutually exclusive events is also there. Mutually exclusive events are if two events like A and B are two events. Okay. Then there is no common element between these two elements, these two events. Then this is called mutually exclusive events. It is also known as disjoint events actually. Okay. So if are mutually exclusive if A intersection B equal to phi. Uh, okay. And independent. Okay, we will discuss about the independent event later on. Before that, we will discuss about the conditional probability. Conditional probability is like we impose some condition, and after those imposition of condition, our like sample space may vary. Okay, our sample space may modify on the basis of those condition. So then we define the probability in a similar manner that we have discussed in the above slides. Okay, so this is called conditional distribution. Suppose the definition will be like this. Suppose we have a sample space omega, sigma field f, and probability function f. So this is a probability space, and we have two events like A and B are two events. Okay, A and B are two events from the sigma field capital F. Okay, and if probability of any event, suppose we have considered A as an given element, actually given event. So probability of A is equal to greater than zero, not equal to, it's greater than. That means it is not an impossible event. It is a possible event. Okay. So if these conditions satisfy, then we can define the condition of probability B under A. So this is like uh, read as the probability of B given A or the probability of B conditioned A. Okay. And this is defined as the probability of A intersection B upon probability of A. Okay, here probability of A is greater than 0, so that it is defined. Not equal to 0, it must be greater than 0. So this is called condition probability. We have already imposed a condition that the event A has already occurred, and then what is the probability of occurrence of B? Okay, so this is a conditional statement. What is the probability of the event B when the event A has already occurred? So it is a conditional probability. From there, we can also define, okay, independent events. Okay, so independent events are like two events which have like no relation in a sim, like just an image may be created in your minds, but its actual definition is like when two events are said to be independent if and only if. Okay, suppose we have two events A and B. These are said to be independent if and only if probability of the intersection of these two events is equal to the multiplication of the individual probability of these two events. So probability of A intersection B equals probability of A into probability of B. When this condition holds, then we say that the event A and event B are independent events. Okay, and there are two kinds of independence actually. Okay, the first one is like pairwise independent, and the second one is like mutually exclusive. Sorry, yes, mutually independent, not exclusive, mutually independent. So the pairwise independent is like probability of AI intersection AJ equal to probability of AI into probability of AJ for all I is not equal to J. If we have like A1, A2, the sequence of events, then probability of the intersection of any two events must be equal to the product of the probability of their individuals. Then those events are said to be pairwise independent. And if it is like okay, okay, and if it is like probability of A1 intersection A2 up to intersection like AK. Suppose we have A1, A2 up to AK elements are there. Okay, a finite sub collection of the sample space from the sigma field. Then the probability of the A1 intersection A2 up to AK is equal to probability of A1 into probability of A2 into probability of AK, where we can take the value of K from like 2 up to at least 2, then 3 and up to the value like up to any point. So this condition holds if then we say that it is a mutually independent. Okay, the first one is, sorry, is it visible?
Yes, sir.
Okay, thank you. Okay, so independence, so pairwise in which only any two of the events are in follow this property, then it is a pairwise independent. And if like A1 intersection A2 is probability of A1 into probability of A2, probability of A1 intersection A2 intersection A3, probability of A1 like into probability of A2 into probability of A3, and so on for A4 up to A4 up to A5 up to A6. Then we say that these are mutually independent events. Okay, and also pairwise independent doesn't imply that the mutually independence. Okay, we have already have like there is a example already discussed in the lectures. Okay, if you may ask, I can like define. Okay, now the properties of conditional distribution is also there. Like again, the first, the probability of A any event A, given the condition, the similar event A is 1 actually. You can solve na probability of A given A equal to probability of A intersection A upon probability of A, which is equal to probability of A divided by probability of A, which is equal to 1. Okay. Also, like if A and A intersection B is 5, then okay, yes. Like if A intersection B equal to 5, if two events are mutually exclusive, then in that case, probability of B given A is probability of like B intersection A upon probability of A. Since this condition is given, so 0 on something comes out to be 0. Okay. And also there are multiplication rule and total probability theorem. So there are multiplication rule which says like if a1 a2 up to an, like if a1 a2 up to an belongs to the sigma field F, okay, are mutually sorry, are yes, then the probability of a1 intersection a2 intersection like an, this can be defined as probability of a1, probability of a2 given a1 into probability of a3 given a1 intersection a2 up to dot dot. The last one will be like probability of an, probability of a1 intersection a2 intersection up to an minus 1. Okay. So this is called the multiplication rule. Okay. So we can like express the intersection of some finite events. The probability of the intersection of finite events may be defined as the product of some particular individual probability. And those probability can be either like simple probability or conditional probability as well. So this rule is known as multiplication rule or multiplication theorem. Okay. And if suppose if in this particular multiplication rule, if like okay, if AIs are independent, then probability of A2 given A1 will be like A2 intersect okay, intersection A1 upon probability of A1, which can be written as probability of A2 into probability of A1 divided by probability of A1, which can be comes out to be probability of A2. So the conditional statement has no meaning when we are independent case. So we can write the probability of, okay, sorry. Okay, so in that case, probability of A1 intersection A2 intersection AN can be written as actually probability of A1 into probability of A2 into probability of AN only. Okay, it is a special case of multiplication rule. In a similar manner, we can define the total probability theorem. Like suppose we have A1, A2 up to are from the sigma field F such that AI intersection AJ equal to phi. This denote actually mutually exclusive. That means any two events are mutually exclusive. This one is for all I is not equal to j. And also union of AI equal to sample space. This is termed as like exhaustive events. Exhaustive events means like all those, the subset or collection of all those events whose union is sample space. Okay, so it is exhaustive event. When these two condition holds, then we can define the any probability like this probability of wait, let me first write and then I will define. Okay, so like A1, A2 are some events belonging to the sigma field, and we have AI like mutually exclusive events. Those events are mutually exclusive and exhaustive events. Then for any event B from the capital F, this probability can be defined as the summation over I, like probability of AI into probability of B given AI. Okay, so this is called the total probability theorem actually. This can like also be used in Bayes theorem actually. Like Bayes theorem is a special case or as a alternate form of conditional probability. So since in conditional probability A given B can be written as probability of A intersection B upon probability of B. Okay, so in Bayes theorem, for any event B, we can write the probability of like we can write the probability of AI intersection B upon probability of B. We can write this na with the help of this formula. We can write probability of AI given B equal to probability of AI intersection B upon probability of B, and probability of B is taken from the this. Okay, and probability of AI from the multiplication rule. Okay, where it comes, sorry, from here only. Okay, so we can write AI intersection B is taken from the multiplication rule, and probability of B is taken from the like this total probability theorem, and we can write this as probability of AI given B equal to like probability of AI intersection B, sorry, not intersection, and whole summation of probability of, suppose we've taken J because I is already used. So probability of B given AJ into probability of AJ. Okay, so this is called the Bayes theorem. Okay, which is used to evaluate the posterior probability. Okay, we are given some probability information and we will consider those probability information to calculate the further probability that is called posterior probability. Okay, so these are all the things that we have already watched or discussed in the first lecture. So up to this point, anyone have any doubt or any question they can ask, or from now onward, we can solve the some numericals on those topics. Anyone have any problem or any question?
No, sir.
No, sir.
Okay, then we will solve some questions. Okay. These are like similar questions that have provided to you as an assignment. Okay, so like the first question is like a simple question. I'll write the question itself. Okay. So the first question is like, what is the probability of A union A complement, where like A is any event from the sigma field. Okay. So we need to calculate the probability of this, and we have the example like 1, 0, 0.5, and 0.25. So can anyone tell me how to solve like this question? What is the answer of this question, anyone?
One.
How? How?
A union A complement equal to sample space.
Okay, yes. Since we know that, like in axiomatic definition of probability, there is one axiom, which is probability of the sample space is 1. And we know that uh, for any event or any set A, okay, A union A complement is the sample space itself. So the probability of A union A complement, which is equal to the probability of omega or sample space, which is equal to 1. So this is our answer actually. Very simple question actually it is. Okay. Now we have another question. Like similar question actually it is again. What is the probability of A union B? We have already discussed this uh, as a property of the probability. So can anyone tell me?
Yes, sir. For any two events, it is probability of A plus probability of B minus probability of A intersection B.
Why should we like subtract A intersection B? Do you have any interpretation for this? Anyone have?
So there is not mentioned that A and B are independent events. So we can't say that
In
this
that,
is right.
Sorry, can you please tell me again?
That is, there is not mentioned that A and B are independent events or those are dependent events. So we can't say that A probability of A plus B minus P of A intersection B, or the not mentioned, clearly not mentioned, no, sir.
Okay, so if it is not mentioned, then I think it is wrong. I mean, you like want to say this, na?
No, yeah, sir. Question is wrong. Question is not clear. So how can we say this is the answer?
Okay,
So
if the
can I
question is not clear, okay, just leave it. Suppose anyone want to say anything more?
can I say anything?
Yeah,
So
sure.
because A and some part also belongs to A and some part belongs to B, which is belong in union. So we subtract the intersection part.
Okay, I got your point actually. Okay, now Ramesh ji, look, I think we are given two events. Okay,
Yes, sir.
A and B are two events only. I don't have any other information apart from this. Okay. Then in that case, is it right or wrong? My question is this, and I think you said it is not right.
So question is not clear. So we can say, assume that those
How
are independent
then?
events also.
Okay,
The
then what
probability
like?
there are chances that those A and B are independent.
What if it is not independent? Suppose my question is like this: A and B are two events only, belongs to a sigma field F. Okay, then how can we explain or express the union of the probability of the event? Is there any other like
Yes.
formula in your mind?
No, sir.
You can tell me. We have discussion actually here.
We can write this way also. If they independent that A intersection B is equal P of intersection is 0.
Okay. Okay. Then
We can
let's.
express this.
Yes. Yes.
It is okay, but I am saying that question is not. We have to check the question. It is clarity mentioned or not.
Okay. I think it is a complete question. Maybe there are some other statements also there, but the main thing is like we have two events, any two events, and we have no information about the events, whether those are independent, those are mutually exclusive, or those are which type of events. Okay. We have only the information about the event that A and B are two events from the field F. Okay. So in that case, we can write this actually. Okay. This is the right
This
formula
yes.
as per my knowledge. Okay.
Okay.
Yes. Suppose if, let me use another color. Suppose these are the right formula actually. Suppose if A and B are disjoint or mutually exclusive, both are similar thing.
Yes.
Okay. So in that case, we have one more information apart from the events. We have one more information that like A intersection B are phi. So this implies the probability of A intersection B are 0. So in that case, this general formula can be written as like this. Okay. So it is a particular form of this general formula. So in general, we can write this. Or suppose we have one more condition. If A and B are independent. Okay. Independent events. So in that case, probability of A intersection B can be written as probability of A into probability of B. Okay. So like probability of A union B can be written as probability of A plus probability of B minus probability of A into probability of B. Or you can take common from any one of this, like I say. Probability of A will be taken as common, 1 minus probability of B plus probability of, sorry, B. Okay. Okay, this can be written. No? And
Yes.
probability of, these are actually just play game with logics actually. Okay. 1 minus probability of B is what? Probability of B complement. We have already discussed the probability, properties of the probability. So it is probability of B complement. Yes. Okay. And plus probability of B. So we can write this actually. This is not like convenience formula, but we can also write this as a formula. Okay. So it is our general formula. This particular star is a general formula when we have only the information like there are two events A and B from the same field. Then we can write this formula. Okay.
Okay.
And yes, Rashmi, I think you want to say like this. Suppose, let me draw a Venn diagram. Everyone familiar about the Venn diagram, na?
Yes, sir.
Okay. Actually, suppose it is set A converted into event A, okay, and set B. So when we take like the union, so A union B is defined like this, na? I think everybody like remember about this. A union B is like this, okay. So this and okay, let me just again, okay. Event A is like this, and event B will be like this. Okay, so this particular section is like counted twice. So that's why we have subtracted one time. Okay, this is like I want like expect the answer, but okay, everything is good. Okay, so this is the case why we have subtracted A intersection B one times from the summation of A and B separately. Okay, still anyone have any like anything want to add? Then they can. Okay, then let's go on question number 3. We have a coin is thrown 3 times. Okay, the question is like a coin is thrown or tossed 3 times. What is the probability that exactly one head is obtained? Okay, the question is what is the probability that exactly one head is obtained? So anyone?
1/8.
1/8. Okay, so we have one answer like 1/8. Anyone else?
Sir, 1/4.
1/4 is the another answer. Okay. Since there are 2 answers, then it must there is at least one of those 2 is wrong. Is there anyone who have other answer than 1/8 and 1/4?
3/8.
3/8. Okay. And one more options. I haven't write the answer like options actually. The question I have written, but option I have forgotten. So let's 4/8 or 1/2 is also there. So let's start. So here the random experiment is tossing a coin 3 times. Okay, see, tossing a coin 3 times or tossing 3 coins simultaneously have the similar sample space. Okay, so our random experiment is tossing a coin 3 times. So okay, wait. So the sample space will be like, since we have 3 coins, na, so maybe the first coin has have head, the second have head, and the third head. It may possible the first 2 have head and the third one is tail. Then head, tail, head, and head, tail, tail. These are the 4 possible combination when we toss 3 coins. There are more 4 possible when the first coin is tail. Head, head, tail, head, tail, 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 head. Sorry. Head, and the last one is like tail, tail, tail. Okay, so there are total 8 possible outcomes of this particular random experiment. Okay, so this is the sample space in that scenario. Okay, now let's define a event A. The event is like exactly one head, na? So define the event A as exactly one head. Okay, so in that case, how we can write in a set builder roster form? Roster form is like there are 2 form of representing set. Na? The first one is like writing a rule. The second one is like writing the element. So the element is called roster form. Here the set A can be written as exactly one head. So if you can see, there are this one, this one, and this one. There are 3 possibilities. So head, tail, 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 head, tail, and tail, tail, head. So there are 3 possibilities. Now you can define the what is the probability of getting A. Probability of getting A means probability of getting exactly one head. So this is like the number of favorable cases. So the number of cases in the event A and total number of cases, that is the number of elements in sample space. So this can be like 3 by 8. Okay. So the correct option is this. So anyone like who told like 1 by 8 or 1 by 4, like they have miscalculated. So have you got how like 3 by 8 has occurred?
Yes, sir.
Yes, thank you.
Yes. You got your mistake, no? Where you have like miscalculated your calculation.
Yes, sir. Forgot
Yes,
Okay.
to
So
count one
Yes,
element.
I thought the question is the result is only in heads.
yes. Yes. No, see, when when we have read any question, just first thing is write down that sample space. Okay. Always use this formula. Wait, let me write the general formula. Number of favorable cases and number of total cases. Okay. Just try to imagine how many numbers are in numerator and how many of them are denominator. Okay, then you can find the probability. It's all based on the logic. Here we have deal with only 3 coins actually. What if we, okay, let's create some more question. What is the probability of getting, this is the sample space. Okay. And I am defining another event B. Like getting 2 tails. Can anyone tell me the probability?
Two by 8. That means 1 by 4.
3 by 8.
2 by 8. Okay. So
3 by
some
8.
of you tell me 2 by
3 by
8
8.
and one
3
of
by
them
8.
3 by 8. Okay, okay. Aryan, you told me 3 by 8, na? And
3 by 8.
Yes.
okay, let's see, na? Yes, yes. 2 tail, na? So here is 1,
Sorry,
2,
sir.
and 3.
I mistook. Yes, sir. 3 by 8.
Okay, okay. Got it, got it. Actually, we have the similar question actually. 1 head or 2 tail. Both have a similar alternative things. Okay. So the correct probability is, sorry, the probability of B is 3 by 8. What if we define the another event C as at least 1 head? Now, can anyone tell me how? Okay, here we are the sigma
7 by 8.
7 by 8.
7 by 8, at least 1 head. Okay, then how it comes to be 7 by 8? Can you explain?
Because
Sir,
there is
because it
only
is our
one instance where all are tails. That is T,
Yes,
T, and T.
yes. Actually, this can be written like this. Na? C have possible at least 1 head. So C have
1
like
1 minus
either 1, yes, yes, 1 minus this also there, or 1, 2, 3. Number of heads maybe either 1 or 2 or 3. So only thing that omits is 0. So there are T, T, T. 3 tails are there. So which is the only case when not a single head occurs. So 7 by 8 is the right answer. So probability of C will be like 7 by 8. You can like frame question from this, okay, itself, and check whether you are right or not. Okay, so we will come to the next question. Which question is this? Question number 3. Okay. So the next question is like, okay, what is the probability of the sample space under a condition event B? Since there is nothing mentioned, so that means B is any event from this F, and this F is defined as like, so these are already understood by default. Okay, these two conditions are already understood when we ask like what is the probability of omega given B? Can anyone tell me?
One.
1. Okay, so our one option is 1. Anyone else? Suppose we write 1/2. Anyone have different answer? Then they can tell me, na? Suppose I have written 1, 1/2, 3/8, and 0. These are the 4 options. Okay, then if we like write probability of A given B, so probability of A intersection B. So this divided by probability of B, and this comes out to be probability of B divided by probability of B, which comes out to be 1. So 1 is the right answer actually. Okay. Okay, now let's come to the question number 5. Okay, we have a question like it's a kind of large question. In a badminton tournament, I can write the question. Okay, like in a badminton tournament, the probability of winning a game is 30%. The probability of winning a game is 30% against half of the players. Against half of the players. Okay, this is called actually type 1. 40% against a quarter of the players, which is termed as type 2. And 50% against the remaining quarter. The remaining quarter of the players, which is termed as type 3. These are the given condition actually. So the question is a game is played. The question is a game is played against a randomly chosen opponent. Then what is the probability of winning? Everyone got the question? Like we are given in a badminton tournament, the probability of winning a game is 30%. Okay, against the half of the player, 40% against a quarter of the player, and the rest 50% against the rest of the player. Okay, then a game is placed against a randomly chosen opponent. Then what is the probability of winning? Try to solve this question and also tell me how to proceed. Can anyone have any idea how to like proceed this question?
Can we use the base theorem?
Base theorem, okay. How can like here is there any condition here? Base theorem are a form of Sorry.
Total probability. Can we use total
Yes,
probability
yes,
theorem?
yes, yes. We can use total probability law. What is total probability law? Na? Like probability of any event B is equal to probability of how can we write like probability of AI and probability of B given AI, the summation of this. Na? So here we use this formula only. So how can we define the AI's event and B event? This is also a task. Na? Can anyone? The question is this: if anyone not like written, then they can take a screenshot or like photo. Okay,
The AI
then we
is
will.
a type of player, type first, type second, and type third.
Okay. Okay, and B is what?
Winning the game.
B is winning the game. Okay. So let's start. It is right actually. Okay, so let's start with this. So AI be the event of playing with opponent of type I. Okay, and B is the event of winning. So here, like from this question, we will first define the random experiment. The experiment will be like AI and B are event of playing the opponent of type I. A1 is for 1, A2 is for 2, A3 is for type 3, and B is the event of winning. Okay, and we are given some prior information actually. Okay, we are given some prior information is like probability of A1. Probability of A1 means probability of winning from the type 1 person. So it is 30%. So it is either 30% or 0.30. Probability of A2 winning from type 2 people. Type 2 people are like, okay, sorry.
So
Type
total
1.
probability should be 1, sir.
Yes. Sorry. I have. Sorry, what are you saying? Can you please repeat? I just tuned out.
Total probability that 0.3, 0.4, and 0.5 are not equal to 1. The percentage
Okay.
that should be 1. So the percentage should
Okay.
be.
Just try to read once the question. Yeah. The percentage should be 1. I agree with it. Just let's reread the question. Like, let me change the color. Okay. In a badminton tournament, the probability of winning a game is 30% against the half of the player. So the half of the player, the probability that the winning the game with those half of the player is 30%. Okay. And 40% against the quarter of the player. And 25% of the players are there with whom we can win the game at 40% chances, with 40% chances. Okay. And the 50% against the remaining quarter. That means 25% is also there. And from those 25% players, the chances of winning is 50%. So here, like if you add this 30%, 40%, and 50%, these are not exhaustive events, na? Then how it comes to 1? It is not necessary. Okay. First, we need to define the exhaustive events. In that particular scenario, what is the exhaustive events? The exhaustive events are those events like half of the player, the first quarter of the player, and the remaining quarter of the player. So 50%, then 25%, and then 25%. So it comes out to be 1. Okay, or 100%. So we have can you got my point?
Yes,
Like,
sir. Yes, sir.
okay. So like in a similar manner, here we have asked one question. Okay, let me show you. if A union B is more than one also, na, the probability of A union B may also comes out to be one, more than one. Then
Yes.
that doesn't mean it is probability. So it is not mutually exclusive in that.
Okay.
So we first like understand the event. Either those events are like exhaustive or not, are mutually exclusive or not. Okay, then we can like comment on about the summation of the probability. Okay,
Okay.
the probability even itself says the probability of the union of AIs, which is equal to probability of the sample exclusive. Okay, or we say that since the union is equal to the sample space, then the probability of sample space is one. Okay, we can take one example if you want. Let me give you one example. Suppose omega equal to 1, 2, 3, 4, 5, and 6. Okay. So what if I say event A is like this 1, 2, 3, 4, and B is like 2, 3, 4, 5. Then probability of A will be like 4 by 6. Probability of B will be like 5. Probability of A plus probability of B will be like 8 by 6, which is greater than 1. So since these two are not exhaustive cases, na, so
Yes,
that's
sir.
why. Exhaustive case means the union should be equal to the sample space and the intersection should be null or 0. Okay, then we can claim about the summation of the probability. Okay, now let's
Okay.
start with here. So here the type 1 percentage people of type 1 percentage people is 50%. Half of the player are type 1 player. So the probability of A is 50. Oh, sorry, not 50. It's 50 by 100 or 0.5. Okay. In a similar manner, probability of A2 will be like 0.25. And the probability of A3 will be like the remaining quarter. So this comes out to be 0.25 as well. And here the probability of A1 plus probability of A2 plus probability of AT comes out to be 1. Okay. Now, under each quarter, we have a winning probability. Okay. So probability that winning, suppose B is the winning probability, event of winning. Under condition first. So what is the probability of winning when we are dealing with type 1 people, type 1 category players? So 30% of the chances we won. So that means 0.30. And in a similar manner, probability of winning when we are playing with type 2 players. So you can see here
40%.
40%. So 0.40. And probability of winning under type with type 3
50%.
or against type 3 people like 50%. So 0. Now we need to find the probability of B, means probability of winning, which can be like calculated with the help of total probability theorem, summation of probability of B given AI I from 1 to 3 into probability of AI. Okay, so let's calculate and tell me what's the answer. So probability of B given A1 will be like 0.30 multiplied by probability of A1 will be like 0.50 plus probability of 0.40 into 0.25 plus 0.50 into 0.25. Okay, so it comes out to be like 0.15 plus 100.
0.375. The final
0.
answer is 375.
Okay, 0.375. 0.37. Okay, and this one is like 0.125. So we can add these three numbers and 1 obviously it comes out to be 0. So suppose you are one of the player, then the probability of winning from those player from the remaining players is 37.5%. Okay, there are different kinds of person. So this is the actual result. Okay. Okay. We will discuss more questions like we are given. Question is this. Let me write it. Suppose two fair dices are tossed. Okay. Suppose two fair dices are tossed, and let E denote the event, and let E denote the event that the sum of the dice is 6. Sum of the dice is 6. And F denotes the event that the first die equals 4. That the first die equal 4. Okay, then we need to calculate the probability of E intersection F. This can also be written as like this. So make sure when you got like this. Okay. So can anyone tell me how to proceed? Okay, what is the random experiment here? Hello.
Yes.
Like the random experiment is here. Two fair dice, so tossing or rolling two dice. So rolling two dice are our random experiments. So the what is the sample space, or how many elements are there in the sample space? Can anyone tell me?
36 elements will be there.
36.
So 2 elements, 4042. 4042. Hello.
30. Okay, 40 elements are in this, like in sample space.
Yes, sample space those 4042.
How you come to this point, like this number? Can you explain?
Sir, they mentioned that the F denotes E denote the sum of the digit 2 is 6. The summation should be 6, the fair dices, and F denotes the first die
Yes.
is 4. So 4 should be fixed, and the
The possible sample spaces would be 36 elements.
Okay, yes. I think who told you like 4042 na? My question is like how you come to this particular number, only logic behind this number, because it is wrong actually, or maybe you want to tell something else that I'm not able to get.
So the E is the
Yeah, tell me,
denote the sum of the two fair dice. Two dice should be tossed, and the number should be we get random number on the dice. That the summation of the dice is 6. Though the two numbers on the dice outcomes should be 6. So here, and F denotes the first digit is 4. So the summation should be,
Yeah.
so 40 is 4, 4042 is wrong, sir. Only 42 possible cases are 42 only. The summation should be 6.
Okay. Look, I'm sorry, but I'm not getting your point exactly. So let's start with the solution, and after the solution, we will discuss again. Okay. I think, okay, maybe you want to say the similar thing, but not getting the answer. Maybe it's possible. My first question is, this is the question, then what is the possible sample space? My first question is this. Okay. So look, since we have two dices, na, so the first one has one, second one is also one. It may be one possibility. 1, 2 is also there. 1, 3 is also there. 1, 4 is also there. 1, 5 is also there. And 1, 6 is also there. Okay. And in a similar manner, 2, 1 is also there. 2, 2. Let me write the whole 36 elements are there actually. Let me write those. Okay. 2, 3,
Yes,
2, 4. I'm omitting the comma. Yes. Want to say anything? You people solve, no? Maybe one of you
Now,
will get the answer. Because we will ask some more questions on this particular sample space. That's why I'm writing. Is there anyone like who are not able to like write the sample space under this condition? If anyone have any doubt, then how to write the sample space in this manner, then they can ask. Okay. Or we can then proceed. Look, we have two fair dice. Okay. So one die has four dice, the similar. So when we roll two die, maybe the first have possibility 1 to 6. Die has also the possibility of 1 to 6. So both have a combination of 6 into 6 that comes out to be 36 combination. And all these 36 combination are only possible. Okay. There is no any 37 elements in this particular scenario. Okay. So this is the case. Now we will come to our question.
Is the
Event
answer
E
1
is
by
defined
5?
as I
sir,
don't have
answer
answer
1
actually, but
by,
I okay. Can tell me what is the answer 1 by 5? And
yes,
is there any other answer? 1 by 5 is
1
one
by
of the
30,
answer you
1
people.
by 36.
Okay, 1 by 36 is the another answer. Okay, there are a lot of difference between these two
5 by
answers.
30.
And is there any other answer?
5.
5 by 36 is also there. Okay, got it. So we have three options. Maybe one of these are correct. Okay, let's see. So the event E is defined as the sum of the dice is 6. Okay, so let's define event E. Sum of the dice is 6. So let's write it in a roster format so that what is the sum whose sum is 6? Look, this is the possible answer. 6, sorry, not that. This is not the possible answer. This is the
1,
possible
1 5.
answer. This, this, this,
This.
this. Okay. So let me write here 1 5 2 4 3 3 4 2 and 5 1. Okay. And F is also there. Sum, no,
4
not
2.
sum. Sorry. The first die equals 4. Okay. First die equals 4. Okay. So what is F? First die equals 4 means if you can see, you will find like first die equals 4, then all these, na? These are the only
Yes,
cases,
sir.
na, where the first die is equal 4. So 4 1, 4 2, 4 3, 4 4, 4 5, and the last one is 4 6. So there are 6 possibilities. Now we need to calculate the probability. Yes,
1 by 36.
we need to 1 by 36 is I think the right one, because there are intersection, na? Maybe you people
Yeah.
not consider that intersection. So what is E intersection F? So both have one thing is common, and that is this particular quantity is common in both the cases. So 4 and 2. So the probability of E intersection F comes out to be number of element, and E intersection F, so it is 1 upon 36. So the person who told this as an answer are correct, is correct. Okay. And these two are not correct. Have you got the question?
Yes, sir.
I think it's
Yes,
simple
sir.
now. Okay, let's create some other question. We can frame the question itself if you have the knowledge of this particular scenario. Then, like, what is the probability of getting? Okay, what is the probability of getting 7? Anyone tell me? I'm not writing these things.
So
Just asking.
once again,
Yes.
question.
What
Repeat
is
the
the
question once.
probability? Yes. We are dealing with the sum of these two numbers. Okay. Then what is the probability of getting a sum of 7?
1 by 6.
6 by 36.
1 by 6.
Yes.
1 by
1 by
6
6
by
or 6 by 36. Yeah. Yeah.
1
What
by
if
6.
I tell what is the probability of getting an even number? This may be,
What?
I don't know the answer actually. Okay, just asking the question. What
Once
is the
again, sir.
probability of getting? What is? Let me repeat the question one last time. What is the probability of getting the sum as even number? Okay, let's start because I don't have the answer as well. If I'm writing, you people can see, na? Maybe it's stating then.
One by 2.
1
1
by
by
2.
2.
1 by 2. Okay.
1 by
Got it.
2.
1 by 2 only.
Okay, let me. I don't have the answer actually. Let me write again. Let me solve also. You people may see like this will happen 1 time, this will happen 2 times, 3 times, 4 times, 5, 6, 5, 4, 3, 2, 1. If you can see or understand what I'm writing here, you'll probably find the pattern. Okay, so I'm asking the sum may be even. So let me circle out. This is the even. 1, 3, 5, 5, 3, 1. This is the point where the sum may be even, comes out to be even. So 1 plus 3 plus 5 plus 5 plus 3 plus 1 comes out to be 2, 4.
18.
18.
Oh,
18.
got it. Yeah, right. So probability that sum is even 18 upon 36 comes out to be 1 by 2. Okay, that's right. What if I'm asking the sum is a prime number? Okay,
Sum is a prime number.
prime number. You must know about the prime number then.
5 by
Are you people
36?
solving now? I don't have answer
15 by
actually. 5 by
36.
36, 13. I'm just asking the
15 by
question.
36.
I will solve after. Sorry, can you repeat?
15 by 36.
15. Okay, sorry. I have heard 13. It's 15 by 36 and 5 by 36 are two of the answers. Is there anyone who have different answer apart from these two?
No, sir.
Sorry?
15 by 36.
15 by 36.
Okay, I think maybe. Okay, let's solve. Okay, then what is the prime number? Prime number are the numbers who have only two divisors, na? The number 1 and
Yes.
the number itself.
The number itself.
So here, yes, let me write here 2 these. There is one even prime number which is 2. So maybe one of the, okay, they are quite different. Okay, so the possible probability that the sum is prime 1, 2, 3 and 4, 7, 6, 13 and 2, 15. So it comes out to be 15 upon 36. Okay, I hope you can understand how to like frame a question from the given sample space. Is it like simple? I think. Still, anyone have any doubt? Then they can ask. Okay, we have one question. Like more questions are there. Like let me write. The question is like. The question. Okay, let's create some questions on the basis of cards. Everyone know about the distribution of cards.
Yes, sir.
Yes, sir.
Yes, sir.
Is there anyone who don't know how the card is distributed? Card means a deck of cards which we are playing. Okay. Everyone know, na? Then we will ask some question. Like what is the okay. When I'm saying deck of card, that means it is a standard card. Okay, fair distribution of card. So what is the probability of getting a red card? Can anyone?
1 by
One-
4. 1 by 4.
1 by 2.
By 4.
So 1 by 2. 1 by 2. 1 by 2.
Okay,
Yes, sir.
there are two.
So
1 by
only 1
2.
by 2.
Okay.
1 by 4, no. Sir,
One by 4 is not okay. Sorry,
yes, sir, 1 by 2.
1 by 2, because there are two colors of the card, black and red. So the probability of red card equal to 1 by 2, and the probability of black card is 1 by 2. And what is the probability of getting ace? Ace
1 by
you know, na?
30. 1 by 30.
2 by 56. 1 by 30.
Okay, 1
4
by
by
13
30.
is one of the answers. 4 by
4 by
1 by
13. 4 by 13.
1 by 13.
okay. 1 by 13
by
is there.
13.
2 by 50, 56. How can I write 56? 52, na? 2 by 52 is also there. Some of you told me. And 4 by 13 is also there. Okay, then how to 2 by 52, how it comes? Anyone?
No, sir. It's wrong answer. I have only told that it's wrong. 1 by
Achha,
13
okay,
is
it's
the
wrong.
correct.
Okay. 1 by 13. And how 4 by 13 is comes out here? Can anyone explain? How do you think? Just tell me, na.
Because
Although it is
there are
wrong,
4
but
aces
yes, there are 4 aces.
in a deck of cards.
Exactly.
Oh, sorry.
Yes, you got your answer, na. So you are thinking, maybe you are thinking in a right way, like 4 is the right, and you explain the right thing. But in denominator, you have to write 52 then, because you are counting the total number of ace cards in a deck of cards, then divided by the total number of cards in a deck, which is 52, which after simplification come out to be 1 by 13, which is the right one. Okay, ace is the card which have A written in the face. Okay, the probability of like getting spades.
One by 4.
1 by 4 is one of the answer. Anyone have different answer?
Kindly repeat the question.
What is the probability of getting a spade? Spade are those cards who have this symbol. Okay.
13 by 52.
1 by 4.
13 by 15 2. 1 by 4 is also there. 13 by 15 2. 52, which comes out to be 1 by 4 after simplification.
Yes,
That means
yes,
yes,
sir.
it is
Yes, sir.
right. Okay. And what is the probability of getting an alphabetical card?
So 16 by 52. That comes to be 4 by 13.
16 by 52. Okay. Is there
9
anyone?
by 13.
9 by 13. Okay. Anyone else?
Sorry, sir, it will be 16 by 52. I found the
16 by
numbers. Yes, sir.
Okay. Anyone else? Okay, look, alphabetical cards, na? Like those cards having alphabets like A, which is ace, J, which is jack, queen, which is Q, and king, which is K. Okay, so these are 4 cards who have alphabets on it, not the numbers or digits. So these are called the alphabetical cards, and everyone have a 4 in number. So we have a total of 16 cards out of 52 who have alphabets on it. So 16 upon 52 are the probability of getting alphabetical cards. Similarly, what is the digit or number card?
So 1 minus 16 by
36.
52. That means
9 by 13.
Number card. Yeah, 9 by 13 is one of the answer. What anyone say different, I think?
9 by 13.
No, 9 by 13. Is there any other answer other than like 9 by 13? If no, then it is the right answer actually. What is the probability of getting a face card?
1 by 52. That means
1 by 52.
3 by 13. Right? 12 by 52.
12 by 52. Okay. Anyone
3 by
else?
13.
3 by 13. I think both are same. Na?
Yes, sir. Simplified
We
form of
divide
12
this,
by
then
52.
both are same. Okay. Okay. Any other answer than this? So the face card. Okay, let me explain. The face card are those cards which have pictures on the card as well. So there are only 3 cards like Jack, Queen, and King who have faces on the cards, and they are a number in 4, each in number 4. So a total is 12. So the number of face card is getting 12 upon 52. Okay. What is okay? Let's create some conditional questions. Like what is the probability of getting an ace when we are given a black card? Now, what is the answer? I'm not writing the whole process or
1 by
just
13.
answer.
1 by 13.
1 by
1 by 13.
30.
13.
30. And anyone else? Anyone else? Is it right?
1 by
Other
26.
people 1 by 20, sorry, 1 by 26. So now there we have two answers. Either at least one of them is wrong.
Sir, right.
Yes.
1 by 26.
Can can anyone 1 by 26?
Yes, sir, it is right.
Okay, how can you please explain how 1 by 26 is right?
Sir, because there are two conditions given. First one is the card should be the black one. So there are 26
Okay.
cards in the black. And the second condition is for ace. So there are two aces in black color. So if
Yes.
we combine these, we get two cards, and there are overall 52 cards.
Okay, now you miscalculate the concept. Up to the last sentence, you are right actually. But at the last point, you make some mistakes. Look, what I am telling before, like what I was telling when we are discussing about the conditional, when we imply some condition, then our sample space is modified on the basis of that condition. Okay. Now, what is the meaning of this? Meaning of this.
The 2 by 26.
Meaning is
2 by,
what is the
2 by 26.
probability
The
of
answer is 2 by
getting
26.
an
Hello.
okay, now the okay. 2 by 26
Hello.
comes out to be 1 by 26 answer. Actually, this is the right answer. I want to like hear how you, but yes, I am.
Sir, actually, I was a bit
My
confused.
question is like how
because
one like
Sir, the
you can
total
tell me,
sample
na?
space, I was getting confused. I took it to as 52 in place of 26.
Yes, please explain it. Explain the answer, sir.
Yes, you can. Okay, yes, please explain. Are you asking me to explain
Sir,
or
I
someone
was
is going to
requesting
explain?
you to explain the, sir, I was requesting you
Okay,
to
sorry.
explain the answer.
I was okay. I am explaining now then. Look, in conditional probabilities, our sample space is modified on the basis of the condition. Okay, just make sure. So we need to find the probability that the probability of getting an ace when we are given a black card. Okay, so probability of getting ace when we are given a black card. Okay, so we have black cards actually. Now our sample space is modified. So we have black cards only. So we have 26 like elements in the sample space only. And out of these 26 elements, we need to check how much and how many numbers of ace cards are there. That comes out to be 2. So 2 by 26 is the answer. Or if in case you are feeling like doubt, we can process with a similar procedural way, like probability of getting ace given in black. What is the probability? Probability of ace intersection black. Is it correct? A intersection B and divided by probability of black. Am I writing correct?
Yes, sir.
Yes.
This is the definition of the conditional probability. Na? Probability of A given B, probability of A intersection B upon probability of B. Now, probability of ace and black. Everyone can like calculate. Na? If you are know the distribution of cards, then there are two cards which are ace and black as well. Okay. And what is the probability of getting black? I see it as like this. Let me write it in a formal manner. It can also be written as number of A and divided by number of black. Both have similar meaning. Okay, because the probability theory comes from the set theory actually. So any formula that is like valid in set theory can also be valid in probability theory. So this comes out to be 2 and divided by 26, which comes out to be 1 by 13. So our correct answer is 1 by 13. Is there still any doubt, like why 26 are there in the denominator? Or if anyone have, then like, they can ask. No one. Okay. Look, like we have completed the question actually. What I have. If still anyone have any doubt regarding any concepts, okay, we are discussing till now, or any further question they have, they can ask me. You have assignments to submit as well actually. Okay. Yes. One of you have asked me where you can find this lecture, recorded lecture. So see, we need to update this recorded lecture on this particular channel, and we will provide the link to the NPTEL team as well. Those they will definitely provide some sheet on which these links are available. Even the PDF is also there in a drive. So either you can access from there, or maybe you can access from this particular accounts and YouTube channels, but they can also provide the same to you.
Sir, I have a question.
Okay, you may take a screenshot or anything that. Yes, yes, sure. Arya, I think you have a doubt, no?
Yes, yes, sir. Sir, it is a
Yeah,
question
please
of
ask.
the assignment which we have been provided. Sir, it is the question number 5 assignment.
Okay. See, currently I don't have the question number 5. You may give me some like hint how to solve. I think cube root of unity you are asking, probably.
Yes, sir. Sir, can I read the question for you?
Uh, yes, you can read the question. Actually, yes, you may read.
Let
Please read
W
one
be
time.
the
So,
yes, sir. Let W be a complex cube root of unity with W not equals to 1.
okay.
A fair die is thrown 3 times
Okay.
if alpha, beta, and gamma are the numbers obtained on the die.
Okay.
Then probability of, sir, in bracket it is given as the W to the power alpha minus 2 plus W to the power beta minus 2 plus W to the power gamma minus 2 is equals to 0 is.
I think this is question. But is still due. No, there is no due date. I think 5 of Feb. Wherever I
Yes,
remember.
sir. 5 of
So
5.
after that, I am able to provide the solution of this question. Look, here
Sir,
W,
please
or actually this is
provide the
omega.
hint.
Yeah, sorry.
Sir, I was saying just please provide some hint so that we can solve it.
Yes, I'm going to. Yes, I'm going to provide some hint too. Actually, someone is asking in chat as well. Let omega be a complex cube root. Yes, sure. Yes, this is the question actually. I have seen. Look, there are cube root of unity, like 1 to the power 1 by 3 have 3 roots, because like the first one is 1, the second one is omega, which you say W, actually it is omega, and the third one is omega square. There are
Yes, sir.
some properties of these cube root as well. These
Yes,
roots
sir.
have some properties. First, go and check the properties of these cube roots. Okay, the first thing, the properties. Like one
Sir, the
of the properties
properties are
like this.
omega cube is equal to 1,
Yes.
and 1 plus omega
Yes,
square is
yes.
equal to 1.
E1 plus omega square is also equal to 1. Yes, these are two of the properties of omega. Okay. Okay,
Yes, sir.
now you have this property. Now you need to think the possible values of alpha, beta, and gamma. Can you tell me what is the possible values of alpha, beta, and gamma?
1 to 6.
Sir, for alpha, beta, and gamma, it will be 1 to
All
6
the three
in each
have
row.
Not equal to 2. Alpha, beta, gamma not
now
equal
you
to
have
2.
getting your
Hello.
like why we should impose this condition like alpha, beta, and gamma should not be equal to 0. Sorry, 2. Is there like mention anywhere? I don't think it is mentioned anywhere. So just think about it. What you are saying, just think about it. Is if it is not mentioned here, is it mandatory to impose this condition on this problem?
No, no, sir.
I'm
It's
not going to tell whether it is. Yes, it is not given that I can read. Okay, just think about it. Should you omit the alpha, beta, and gamma equal to 2 from the given question or not? Okay, and for that you should solve in both the cases and you will find the answer. Okay, one more question, like one more hint actually is there. Okay, you have the ranges of alpha, beta, and gamma. You have the properties of omega. Okay, combine these two, you will find a pattern actually. Okay, that I can say. You will find a pattern from there. And once you get the pattern, you are able to find the probability that the probability that, sorry, where is the probability? Yes, this is the probability. The probability of omega to the power alpha minus 2 plus omega to the power beta minus 2 plus omega to the power gamma minus 2 equal to 0, equal to 1. That definitely comes between 0 to 1. And you are like able to solve. Just combine these two properties, the properties of cube root of unity and the just think about the scenarios how alpha, beta, and gamma vary. Then you will definitely get the answer. Okay. Try this. If I think our next class will be before 5 of Feb. After due date, like I am allowed to solve the questions, the current assignment question as well. So I will definitely provide the answer once the due date is over. Okay. Till then, I can only give some hints. And if still you want some more hints, then you can ask. Okay. I will brief some more, but I think that's enough. Na? Can you get na, what I was trying to say? Anyone? Hello.
Sir, actually, we have to think like the possible outcomes of alpha, beta, and gamma independently, and then combine it with the rules of the gamma, omega.
Exactly. Yes. Okay. Let me give one more hint. Just give one more like comment. How many cases are there for the consideration of the different values of alpha, beta, and gamma? Can you think about it? Just say what you are like thinking. Anyone? Since we are given the value of alpha, beta, and gamma comes from the rolling a 3 dice. Okay. The outcomes of rolling of 3 dice will get alpha, beta, and gamma. Then what are the possible scenarios for alpha, beta, and gamma? I think this we can discuss. 0. Okay. How it comes out to be 0?
2 minus 2 is will 0 now. When alpha, beta, gamma are the die values, in on the dice it will be possible 2. So 2 minus 2 is 0. The cubic unity that sir 1 to on the cube we will get the number 1 to 6, and we know that the on the cube unity of the cubes that omega power 1, omega power 2, omega power 3. when we take that mod of the 6 values, then we will get 0, 1, 2. The remainders are 0, 1, 2.
No, I think you are going on the wrong track. Just look, okay, let me start again. Okay, we are here. The question is omega is the cube root of unity. Okay, we have 3 cubes, 1 omega, omega square. First, omega have different properties, like 2 of them are written here. Omega cube equal to 1, 1 plus omega square equal to 0, I think, not 1. I have written wrong. Okay, so these are 2 of the properties of omega. Now we have the different values of alpha, beta, and gamma. Just imagine we have the different value of alpha, and it is
1 to 6.
and it is 1, 2, 3, 4, 5, 6. Just try to think what for different value of alpha. We need to calculate this, na? We need to calculate this, na?
Yes.
Which is quite complex actually. So let's try to simplify this particular equation, which is given in omega to the power alpha minus 2 plus omega to the power beta minus 2 plus omega to the power gamma minus 2. Okay, if you are able to simplify this particular expression, then you can definitely solve this question. Okay, in a similar manner, once you get the point that how the impact of varying of alpha on this particular expression, similar will be applied for beta as well and for gamma as well.
We can take permutations like.
Yes, there are combinations.
actually,
Yes,
I want
there are possible combinations. Yes.
Sir, in
Yes,
the question given, there is omega to the power gamma minus 2 is equals to 0, or it is the omega to the power alpha minus 2 plus omega to the power beta minus 2 plus omega to the power gamma minus 2 whole equals to 0.
Look, my first question is, in any probability question, first try to frame the sample space, and after that try to find the favorable cases.
Okay, sir.
First, yeah, because what is the probability? We need to find the probability, which is number of favorable cases upon total cases.
Total number. Yes, sir.
Okay. Then we have only 2 aims. First, we need to find the total cases, which is nothing but the elements in the sample space. And after that, you are able to imply this condition, which is given in here as expression like omega to the power alpha minus 2, omega to the power beta minus 2, and omega to the power gamma minus 2. This can be only find out when you are able to calculate the total cases. Okay, the number I'm not going to tell because it is not allowed to us. Okay. Just try to think. What comes under
Total
the denominator.
216.
How you can say 216?
Sir, 3 dices, no sir, 3 cube, 6 cubes. Possible total outcomes.
Yeah, maybe you are. Maybe you are right. Okay, I'm not comment on this. You are actually thinking in a right manner. Okay, just try to go in that track. You will find the answer. Everyone, just try to think how many cases are there for different values of alpha, beta, and gamma. And after that, what are the possible your favorable conditions? Okay, you need to simplify this particular expression. You will find the answer. Okay, and for that
sir, we
purpose,
will try.
you need to know. Yes. For that purpose, for the simplification of this expression, you need to know about the properties of the omega and omega square. Okay, cube root of unity. That means. Okay,
Yes,
then
sir.
you can definitely solve this. If not, then we will be discussing in the next week. Okay.
Okay, sir.
Is there any other question?
No, sir.
No, sir.
Okay, then if there is no question, I think we should conclude here. Okay, let me stop the. Okay, thank you everyone for this session. Let me stop the recording now.